Hi, in this video I'm going to make a 3D scan of this bottle cage. It's made from aluminum and it grabbed the bottle by using the spring force. Quite thin, about 1.6 millimeter, and it looks like plastic but it actually made from aluminum. And then I will reverse this with the FreeCAD, and then I will try to make a 3D printable version of this bottle cage, see if it works. Okay, for this scan I will use the Raptor. This one is Raptor X, but the part is small, so I will use 7 lines laser. You can also use the Raptor original, Raptor Pro or Raptor X, so they all share the same 7 line blue laser. As you can see here, that I have already applied the markers. It's a 6 mm marker because we have a very narrow strip here, so only 6 mm that can be attached into this frame. I put about 45 markers on both sides, this side and the other sides as well. This is very thin. Even though it's a very thin frame, but the Raptor can detect the position of the marker when it's only 1 millimeter away. So there is no issue with the Raptor for detecting the markers on the thin part. Okay, so I won't be using external marker because this part is very thin and it requires a global marker and continuous scanning. So I need to scan. I will make only one scan, but I will stop the scan to erase the turntable, which you will see in a minute. So this will be a single scan without merging. Okay, let's get started. Okay, I'll use 0.25 for the resolution because there's not much of the detail in this object. Click on scan. Okay, and next I'm going to choose a global marker. I will handheld it because it's more convenient if I will handheld it. And then I will increase the brightness for the infrared. Start the scan. So you need to do a global marker. So I have 45 marker detected. So now increasing 46. 46 will be all, I think. It should be counting how much of the marker that you put in. Yeah, 46. That's it. Okay, we have 46. Before we start, I will place this into a tray, and I use this small a pyramid to support it because it has a sharp edge and line contact, so that it will be easy for me to remove. It's okay if you move a bit when you scan because we're not using the external marker. So I start the scan in this orientation first. I click on the point cloud, click on yes, right? And next I'm gonna choose the parallel lines. If I choose the 34 lines, all of the table will be scanned. That's not what I want. And 7 lines. It's better when you scan a dark surface object. So increase the brightness of the 7 lines a bit. It's 2 step, okay? Because it's black color. Okay, start the scan. Okay, I think we have everything. Okay, next I'm going to complete the scan, and then I will release the turntable. so that it won't be blocking when I reorient the position of the scan. Okay, next I'm going to click here, continue scanning, right? You don't have to do global marker again. So we place the bottom cage in a new orientation. Okay, so this will be a lot easier to remove. Okay, I will continue the scan. The laser brightness is already kept at the same value. So start the scan. Okay, I think we have everything. Okay, I stop the scan. I will erase the turntable, this part. Okay. I will infuse the point cloud 0.25. At some time we come back, but at least it's easy to remove. The bottom part is not scanned, so it should rescan it. I didn't see that it didn't scan. Okay, I will continue the scan one more time. So we need to doing because the bottom part is not all scanned. So this time I will hold it in my hand. This should be better. This one is more complete. So I will remove the noise. Okay, let's see 0.25. Okay, now the bottom part is cleaned. Yeah, it looks much better than before. And this part, it's maybe I deleted too much. But I'll try to trim it. Okay. So you shouldn't put the marker closer to the edge. It will give defects on the surface. Okay, let's match it. We have about 300,000. Okay, this is the mesh result. This is small defects here. I think that's from when I cut the point cloud and go to edit. I'm going to repair this hole filling manual. I'm gonna fill it with the plane. Confirm. Okay, that's much better. Going to export this as a point cloud. Anyway, export SC format. Alright, now let's move to CloudCompare. Okay, here's in CloudCompare. What you have to do is just drag the files into CloudCompare. Click on apply. Now you have your 3D scanned. Okay, next you are going to align this to the XY plane. I'm gonna click on these two level tools. Click on the object first. Click on level tools. I'm gonna pick 3 points. 1, 2, and 3. Now our object is aligned to the XY plane. If I look from the top view or the side view, see here, it's aligned to the XY plane. And let me check. Now the Z-axis is upside down. Click on the lower right corner. Z-axis is upside down. So I'm going to rotate it along the Y-axis for 180 degrees. Click on forward. click on check mark. Now it's pointing toward the z-axis, which is the correct axis. Next, I'm going to click on the top view, and I will align it along the z-axis. I move this object closer to my monitor edge, and then I use my left click mouse to rotate it. I shoot the slotted holes here for referencing. Okay, that's pretty close. Click on the check mark. Now your object is aligned. Because we don't have any noise, it's very clean scan. So I'm going to move the center of the object to the origin point. I do this by clicking on Tools, Registration, move bounding box center to origin. Now it's done. Now your box, if you look at the property box here, the global box center is 0, 0, 0. So everything is in the center. Okay. Then you have to click on Save, and you have to save it as a PRY format. This is the only format that can be opened in the FreeCAD. Save it as a PRY format. Okay, next I'm going to move to FreeCAD. Okay, here's a FreeCAD 1.0. Have to tell you first that I'm new to FreeCAD. This is my third project with FreeCAD, right? Usually I will use Autodesk Inventor, but FreeCAD is a very good CAD software for doing a reverse. Okay, next I'm gonna click on parametric part, and then I'm going to import the files that we export from CloudCompare. Okay, now we have our point cloud here in a default color, which is light gray. I'm going to click on that, the point cloud, change the point size to 1. Now it's lighter, see? And then I'm going to change the color to something very bright. It's either be green or yellow. Click the bright color, so now you can clearly see everything. And if you look at the top view, it will be aligned to XY plane. If I turn on the plane here, see, it's all aligned to the XY plane. See, the center of the point cloud is in the origin point of the CAD files, so we can start tracing. I have already made this model, so to make it quicker, so I will show you the steps that I took to model this bottle cage. Okay, this is the end result, the bottle cage that I'm going to show you the steps that it takes to make this model. You see that I put the model with the transparency. How to do that? Click on the body, and you here on this property windows, you see transparency. I usually put it to 50%. So with the 50%, you can clearly see the point cloud inside, and you know that you can trace it correctly. You see the tracing here, it's quite accurate. And also the inner side of the cage, it's will be the part that will touch the bottle, so it has to be precise. And I have increased the thickness of the bottle cage from 1.6 millimeter to 3 millimeters because I'm going to print it with the FDM printer. 1.6 millimeter is too thin. Okay, so let's start with the first step. Okay, this is the first step that I took. I draw this profiles by using this sketch. See here, if you click here, you get a section view. What I do is I trace the inner side of the circle. It's not fully circle. It's the I need to make two arcs together to make this profiles. It's not a full circle. So and then I offset this line for 3 millimeter, so I can get this bottle profiles. What I do is when you do offset, there's something strange with the FreeCAD. You need to click on the lines that you want to offset, and then you click on this little icon here, offset. When it offset, it will offset both inner and outer. So if you want to offset 3 millimeter, you click on 3 millimeter, and then you need to delete the lines on the inside. It's quite strange. After that, I make I click on the sketch and click on this path to extrude this to 120 millimeters. So see here. So I extrude it just passing this point and passing this point. I extrude it longer than I need because I'm going to cut this profiles in the next extrusion. Okay. Next, I cut this profiles. See, it's already cut. How I do that? I create a sketch on the XY plane. And this sketch, see this white line that I traced with the point cloud. See, this will be a closed loop sketch. I have 1, 2, and 3 closed loop sketch that I need it for cutting to make this shape. And after that, I click on the pocket. This one, this function will cut the solid with the sketch. I click on the pocket, and it will detect any closed loop in the sketch and cut it. I have 3 sketches, and it will pick all if they have a closed loop. Next, I'm going to create the support for the ball here. So what I do is that I just I create this sketch here. This is the sketch that I create. I use the click here, create external geometry, and then I copy this all lines here and create a sketch over this, and then I mirror it to the other side as well. So I have 2 sketches, and then I use the pad command to extrude it. Now I extrude it to 11 millimeters, just above this, because I need to make this extension separately. It has an angle. Okay, next I extrude this by making a sketch on the XY plane. This one, I create this sketch. See this sketch, I trace it. So I trace the sketch here. I trace it and use a 3 millimeter as a thickness, and then I extrude it. See here, extrude it. My next process is that after I extrude it, I cut with the 2 sketch here, make it curve. I cut with the 2 sketch so that it will have a round profiles. Okay, next what else did I do? Okay, next I'm create a lock for the bottle. So I just tracing with the point clouds, and then I extrude it. Okay, I extrude this one, and then I make a fillet here. Make a fillet. You can use this command fillet, and then I create a pocket holes. I think, yeah, slotted holes. You can do this by create a sketch on this plane and make a pocket holes, and then I allay using the allay command here to allay this pocket hole into this position. To create slotted holes, I use this create slot command. You could try it, it's not difficult. I don't want to make a video too long. Okay, next, final step. Okay, the final step. I create this 4 sketch, 1, 2, 3, 4 on the XY plane. And if you look here, this sketch will follow the curve of the point cloud. See? So that when I cut it, it will create a round profile. So if I don't do this, it will be like this. So if I cut it, it will be more round. This edge will be more round. It's more complete. So that's it. Click on export as STL, and then I send it to the slicer for printing. FreeCAD is a good tool. I mean, it's not as good as the X Inventor, but it's free. Okay, if I put the bottle cage in this orientation and I try to slice it, I use 3 support, and what I get is this. Not much of the support, but I think there will be an issue with the cage here. It might break, I think, if I print in this orientation. So I'll try to print in another orientation. Let's try this. Slice it. This will be 1 hour printing. The grip here won't be as strong, but the cage holder would be stronger if I print in this orientation. And the lower part can be print without support. Not much of the support, I guess. Okay, so I think I'm gonna print this in this orientation. Okay, nothing breaks this time. Support is very easy to remove. Okay, let's take a closer look at the 3D printing result. This part is printed without the support, so it's overhang. If you look closely, the surface is not very nice. I mean, it could be better if it put a support here. And this part is print in this direction, so it could be very brittle. But this part is printing in this direction, so it's give a spring action. Let's compare it to the original one. I think it's about the same weight, but this one is 3mm, this one is 1.6, and if I squeeze it, the metal one is stiffer, so it's this one yeah, it's quite tight to put the bottle in. And this one, yeah, it's a bit loose, see, because the spring force from the plastic is much lesser than the metal. So if you want to make it tight fit, you probably need to reduce the diameter. I think it's not too bad. I mean, it's not going to fall down. There's a lock here, so it's not going to fall. Okay, alright, thanks you guys for watching. I'll see you in the next video.